Welcome to the Unit 8 Lesson 2 notes. The first thing I want you guys to do is Google look up the definition of a parallelogram. You can write it in this box here. I'm gonna skip that for the lecture, but you guys should look it up on your own. Um, oops. So for a parallelogram, use the arrows again to indicate which two sides are parallel. So we see that these both have one arrow, so they're parallel, and then these have two, so these are the sides that are parallel. So that's just how you notate which sides are parallel. Now we're going to jump right into this with the proofs. So we have given ABCD is a parallelogram, prove that segment AB is congruent to segment CD and that segment AD is congruent to segment CB. So as we know, first reason is always given. That's an easy place to start. Okay. What is given? Well, ABCD is a parallelogram. And I'm going to do a little symbol for parallelogram instead of writing it. So that means ABCD is a parallelogram. Okay. Now, what does that mean exactly? Well, if you got your definition of parallelogram above, you know it has something to do with sides being parallel. So we got AD is parallel to BC, and AB is parallel to DC. Now, how do we know that? Well, we got a vocab word, so that means to the bottom right. That's the reason. So that's the definition of a parallelogram. Should have just drew the symbol there. Okay. Now we know that the sides are parallel, so I'm gonna draw that up on the picture. So if those sides are parallel, that means that DB is in fact a transversal. So DB is cutting parallel lines. So now we're going back to Unit 3 where we talked about parallel lines and a transversal. So the fact that DB is a transversal means that we have some angle measures that we know. So first, we know that angle ADB is congruent to angle CBD. So we got ADB and we got CBD. Now, how do we know that? Well, they're on opposite sides of the transversal. So that means that they're alternate interior angles. And alternate interior angles are congruent. We also know another set of alternate interior angles. That angle CDB is congruent to angle ABD. So we got CBD, or CDB, excuse me, and ABD. Again, they're on opposite sides of the transversal, so it's the same reason, alternate interior. Okay, now we got two pairs of angles, so we need one more piece of information to prove that these triangles are going to be the same. So the transversal split the parallelogram into two triangles. Okay, so The last piece of information we need, we either going to need an angle or a side. And if I look at this, well, I can see that both of the triangles share DB. So DB is congruent to itself. And that's going to be, anytime you have something congruent to itself, that's going to be the reflexive property. So reflexive. So now we got a congruent side with two pairs of congruent angles, and the side is in the middle. So now we can say that the two triangles, triangle ADB, ABD, is congruent to triangle CDB. Okay. And how do we know that? Well, we have two angles, pairs of angles, with the side in the middle. So we got angle, side, angle. Now that we know that all of the triangles are congruent, we can say that all the parts of the triangle are also congruent. So what it asks us to prove, AB is congruent to CD and AD is congruent to CB. We can now say that because we know that the triangles are congruent. So that means all the parts have to be congruent. And we learned the term for that a couple units back, corresponding parts of congruent triangles are congruent. So you don't have to write all this. You can just write CPCTC, but I wanted to make sure I showed you guys what that was. So corresponding parts of congruent triangles are congruent. You can just write CPCTC. Same thing. So because the triangles are congruent, all the parts are. So we can prove that AB is congruent to CD and AD is congruent to CB. Okay. Moving right along. I'm going to skip the theorems. You guys can look at those on your own. I'm going to go down to using properties of parallelograms. Make sure you look over the theorems or else this part is not going to make sense when I start explaining. Okay. But it tells us ABCD is a parallelogram, find the lengths and angle measures. Okay? So one for A, it says find AD. Well, if you look at your parallelogram properties, one thing that you know is that opposite sides of a parallelogram are congruent. So that means that AD is just going to be A because it's across from BC, which is A. For EC, or for B, we have measure of angle ADC. So if we look at ADC, we're talking about this whole angle right here. And we know a couple things about the angles of a parallelogram. The most important is that the opposite angles are congruent to each other. So that's how we're going to find ADC. So up here we got 65 and 45. So that means that this angle in total is 110. And because ADC is across from that one, we can say that that's also 110. Opposite angles are congruent. Now if we look at CEC, we also know that the diagonals of a parallelogram bisect each other. Okay? So that means that each diagonal is cut equally in half. So if AE is 5, then EC has to also be 5. And last, the measure of angle BCD. So we're talking about this angle as a whole. Okay. the last thing we know, or one of the other things we know about the angles of a parallelogram is that consecutive angles, so angles right next to each other, are supplementary. So that means if two whole angles are next to each other, if the blue one is 110, then this one has to be 70. Because 110 plus another angle has to equal 180. That makes the consecutive angle 70. Okay. And it doesn't ask us this, but one other thing we can also say is that BAD, angle BAD, is also 70 because it's opposite, and opposite angles are congruent. So just to recap, for A, opposite sides are congruent. For B, opposite angles are congruent. For C, the diagonals bisect each other. And for D, consecutive angles are supplementary, meaning that they add up to 180. I'm going to do the first exercise, give you the answers, and then you guys could do the rest of them on the next page. So I know that A has to be 15. Opposite sides are congruent, and I know that B has to be 135 because opposite angles are congruent. So you can take a minute and do the rest of them. Use your properties, use your theorems on the last page to figure it out. Next, I'm going to do the ones that involve algebra, which is just a little harder. It's not that much harder at all. So if I scroll down, so we gotta find the variables, find the value of the variable. So we got 8, 4, 2y, 2x minus 6. 8 and 2y are opposite. And 4 and 2x minus 6 are opposite. And the properties of parallelograms tells us that opposite sides are congruent. So 8 is equal to 2y. They're the same. So 4 is equal to y. And we can do the same thing for the blue sides. We got 4 equals 2x minus 6. Add 6 to both sides. We got 10 equals 2x. So x equals 5. So for these, we got y is equal to 4 and x is equal to 5 as our values for our variables. Okay. For B, we have to find the diagonals and we have opposite sides. Now, in red here, it should be 3y plus 1, not 3x. So that should be a y. So we got opposite sides again. They should be congruent. So we got 2x minus 1 equals x plus 5. Take away x. We got x minus 1 equals x plus, or equals 5 plus 1. So we got x is 6. And now we know that the diagonals bisect each other, so the two pieces of the diagonal have to be the same. So we got 10 equals 3y plus 1 minus 1 minus 1. 9 is 3y. So 3 is equal to y. So for B, we have x is 6 and y is 3. So I want you to take a second, complete the exercises below. Remember consecutive angles. So for number 1, consecutive angles are supplementary. So that means 4x plus 2x has to equal 180. Number 2, remember that opposite angles are congruent to each other. So those two are equal, and these two are not. So those two will be equal, but it's not asking you to find the angle. It's asking you to find the side. So these two sides are equal to each other. And number 3 is just like example B. So I think you guys could do that with no help. So take a second, finish those. I'm going to move on to the next proof that we have. What I thought we had. Let me see. Oh, no. Did they skip the proof for you guys? Okay, this set of notes doesn't have the proof on it, so I'll do that in class. So don't worry about that. Then you have the theorems that prove quadrilaterals are parallelograms, so take a look at that. And then I'll do one last set of examples for you guys. So what they're asking us to do is show that these coordinates A, B, C, and D are the vertices of a parallelogram. Now there's 3 methods you can use to go about doing this. So first, show that the opposite sides have the same slope so that they are parallel. Okay? So you just got to find slope. Slope of AB will be 4 minus 0 over 3 minus 2, so that would just be 4 over 1. Slope of CD would be negative 4 over negative 1, or just 4 over 1, same thing. Slope of BC is going to be 2 over negative 5. And slope of DA is going to be 2 over negative 5 as well. So you can conclude that the opposite sides are parallel because the slopes are the same. So we can say A, B, C, D, it is a parallelogram because opposite sides have the same slope. So that's the first method. The second method you can do is show that opposite sides have the same length. Now I know this is your guys' most favorite thing to do in the world, but you would have to use the distance formula to find length. So you got to take the points. You got x2 minus x1, and you guys can decide whichever one is x2 and x1 and y2 and y1. Just make sure you keep it consistent. So for AB, if you did all that, you would get square root of 17. For CD, you would get the square root of 17 as well. For BC, you would get the square root of 29. And for DA, you would get the square root of 29. So we can conclude that it is a parallelogram because opposite sides are congruent. And then finally, method 3, show that one pair of opposite sides is congruent and parallel. So we got to find the slopes and the lengths. Luckily, we can just look in our other 2 charts to fill in this information. We can look in the tables that we already did. So slope of AB we figured out over here. So we got 4 over 1. Slope of CD we figured out over here. So we got 4 over 1. Length of AB we figured out over here. So we got square root of 17. And then length of CD we figured out over here, which is also square root of 17. So the conclusion here is that we have parallel sides because of slope. So parallel sides because same slope for 1. And then for 2, we have a pair of opposite sides are congruent. So 1 pair opposite sides are congruent. So those are the 3 ways you can prove that a shape is a parallelogram if you have the vertices. So the last thing you guys need to do is use the 3 methods at the bottom, complete those problems, and then I'll go over anything that you're unclear of in class. Hopefully you guys will have enough time to finish the classwork. Hopefully you guys won't have to have a quiz. So that's all for lesson 2. I'll see you next time.